In this example, we're going to calculate the class average on a quiz for 10 students. And to do that, we're going to read in 10 grades from the user at the keyboard and add them to a total and then divide that total by 10. Now, because we know precisely how many grades we need to input, we can use what's known as counter-controlled iteration for that purpose. And in this example, we'll do that using the so-called while iteration statement. Now we're also going to take a look at a couple of other key concepts in this example. One is called definite assignment of local variables, and it's a requirement in C#. And the other is what happens when you do integer arithmetic, specifically in the context of division. So let's go ahead and run this program first. And you can see it prompts me to enter a grade, and it's going to do that 10 times in this example because we know we have a course in which there are 10 students. So I'm just going ahead and responding to each of the prompts here with a value. And as I get to the point of entering the 10th value, at that point it's going to display for me the total of all the grades that were entered, in this case 848, and you can see it tells me the class average as well. Now, when you divide 848 by 10, what you expect to get out of that is 84.8. But when you have an integer total divided by an integer number of grades, 10, the result is an integer. In C#, when you divide one integer by another integer, you get an integer result, and any floating point part of what would have been the normal result in arithmetic is simply truncated. So the 0.8 is chopped off, giving us only 84 in this case. In the next example, we'll use floating point arithmetic to get a proper average for our student grades on an exam. So let's go ahead and take a look at how we implemented this particular program. And this is just a simple program fully implemented in the main method of our class average class. And by the way, this solution obviously I already opened from the lesson 5 examples that you downloaded in along with these videos. So in the main method here, you can see that we have two local variables declared in main. One is called total and one is called grade counter. They're both integers. And they're both assigned initial values directly in their declarations. So 0 for the total because we have not yet read in any values to add to the total. So we start from 0. And the grade counter is set to 1 in this case. We know that we're going to read in 10 grades, and we need to keep track of that, so we're actually going to count from 1 through 10, iterating 10 times to grab a grade from the user each time and add it to our total. Now, one thing that's extremely important about lines 10 and 11, and specifically about local variables, is that before you can use the value of a local variable, you must so-called definitely assign it a value. At line 10, we are definitely assigning a value to total. We are giving it the value 0 from the moment it is declared. And at line 11, we are definitely assigning the value 1 to grade counter. The reason this is important is that unlike instance variables of a class, local variables do not get initialized for you. So you must initialize them yourself before you use them. So just as a for example, watch what happens if I remove the equals 0 on total here and I don't initialize it. Now all of a sudden I've got an error message down here popping up with the red squiggly line at line 18 saying that I have a use of an unassigned local variable called total. It's unassigned because we have never given it a value, which means that the compiler doesn't know what we should start with as our total value in this case. So by putting back in the equals 0, notice the red squiggly line goes away here. So in C#, it is required that every local variable receive a value, be definitely assigned a value, before you try to use that value, for example, down here in a calculation. Now, at line 14, we have a while iteration statement, which starts with the while keyword and a condition in a required set of parentheses, and its body is defined by a set of curly braces. If the statement has only one statement in its body, then you don't need the curly braces, but we always include them as a good programming practice. So if the condition grade counter is less than or equal to 10 is true, which it is at the moment because we just set it to 1, then we're going to display enter grade. We are going to read in a line of text representing that grade and convert it to an integer, store it into the variable grade, which is a local variable at line 17. And again, we are assuming that the user enters valid grades. Remember, it's possible that if you pass in or you type in rather a non-integer value, that line 17 could fail and terminate this program with what's known as an exception. And in fact, if I take a moment to just go ahead and run the program one more time, let's say I type hello, which of course is not an integer, then you're going to get this ugly error message being displayed. This is known as a stack trace, and it's telling me that the input string was not in a correct format, and it even shows me what was going on in the program at that time. Specifically, in main, we had called the parse method, and in turn, it was calling other methods to help it perform its task, but parse failed because I didn't give an integer value. So clearly, you don't want your users to see messages like this, which is why it's often important to do input validation before you do things like try to convert a non-integer value to an integer with the parse method. So we're going to read that value in, turn it into an integer. We will then take that grade value, add it to the total, and store the result in total. And later on in this lesson, we'll show you how we can shorten statements like those at lines 18 and 19 using some of C#'s other operators. So we add the grade to the total, then we add 1 to the grade counter and store the result in grade counter. That increments the grade counter so that at some point in the future, our condition is going to become false. So grade counter will become 2 at that point. 2 is still less than or equal to 10, so we'll execute these statements again, and we'll continue doing that repeatedly until eventually grade counter becomes 11, at which point 11 is no longer less than or equal to 10, and we will move down to line 23. Now at line 23, we perform a simple division of the value of total divided by 10. Total is an integer variable. You can see that popping up in the tooltip as I hover over it. And 10 is an integer literal. Anytime you have a whole number literal, you can see here the compiler thinks it's an int32. Int32 is the type name that from the .NET framework that corresponds to the int keyword in C#. So int is simply a shorthand for int32, and in fact you even see that here in the tooltip as I hover over the int keyword. So because we have an int divided by an int, the result is an int, and that's why we get the truncation when we divide by 10 and store the result into the variable average. And then finally at lines 26 and 7, we display the value of the total and we display the calculated average. And by the way, we could have taken this total divided by 10 this total divided by 10 and placed it here where average is so that we don't even need a physically separate average local variable. By the way, average also is being definitely assigned here before we use it down at line 27.